Hi there, Blue Day students, gobble, gobble, gobble. Hope you had a good Thanksgiving, and so sorry that we are not in school today for you to learn stuff, but we are going to make it okay by having you learn a little bit on your own so you're still kind of okay for next class. There are 3 total things I'd like you to take away from this video, and here they are. Meaning of instantaneous velocity, how to create velocity time graphs when the position time graph is curved. We've done with straight lines, now we're going to do curves. And what the slope on a velocity time graph means. Here's the thing about video learning. Watching a video is not learning. So you need to do some stuff as a learner. First of all, at the end of the video, you should ask yourself, do you know these 3 things? And second of all, throughout the video, we're going to have pause points. We're going to say, pause the video. Try this on your own before I show you how to do it. We've talked about learning a lot, but you can fool yourself into thinking you've learned if you just watch the video and go like, yes, that makes sense. But if you stop, try it on your own first, and then get the answer. That's how we really make meaning of something. So don't fool yourself into thinking you've learned just by watching. Make sure you pause and try. This whole experience will be short and quick, but it will be very valuable for you to try stuff on your own at the pause points. Hey, look, I have a little picture. What is this picture? Well, it's a ramp and a car that's going up a ramp toward a motion detector. So just imagine the ramp is on bricks or something. And at 0 seconds, the car is already moving up the ramp. Nothing's touching it, so you can imagine what's going to happen if it is heading up a ramp, that it probably won't be constant velocity. You can see that there's a 0 meter mark at the motion detector. The motion detector thinks it's at 0 meters, and it sees about 1 meter and about 2 meters away. So positions are given, and here's the beginning part of this problem. What I'd like you to do is to create a motion map showing how this car goes up the ramp and how it goes back down the ramp. So when I say I'd like you to do it, I mean, oh, stop, pause and try it. Try it on a piece of paper, and then when you're ready, continue the video to see the answer. Okay, I'm waiting. No, really, pause. No, pause, no, do it. You gotta do it. If you just wait for me to show you, it won't be learning. You wanna learn. You wanna make meaning, so try it yourself. Hopefully you try it yourself. Here's what a motion map would look like. It would go up the ramp and slow down. So we'd expect those dots to get closer and closer and closer together, and at some point it probably would stop for an instant. So we'd show that those V arrows getting shorter. Maybe it even stops, and at some point it's going to turn around. Remember with turn around, we go either above or below to give ourselves room. It's going to go down the ramp and get faster, so those arrows are going to get longer again. This is the point where I'd teach. If I was teaching, I'd ask, what questions do you have? But you have to ask that of yourself. What questions do you have? And see if this makes sense to you. And if it does make sense, what you should now be able to do, since we see at various points of time where along the number line the object is, you should be able to draw a position graph. This is not something we've done much, right, with the position graph where the velocity is changing. So you have to think to yourself, what would it look like if the velocity is changing? We don't know the time scale, but we do know something about the position. 0 position, 1 meter position, 2 meters positions. So try on your own to graph the position versus time. No, pause, really, pause. Stop the video, try it. You gotta try it, it's worth it, try it. Okay, hopefully you paused. I'm about to go over it. This starts at about a 1.5 meter position or so. So it starts here. And as time goes on, the position gets less. It gets down to a position of like maybe about 0.5 meter. So at some point it's gonna get down to this spot. And then the position gets bigger again, basically back to that 1.5 meter spot. So at the end it's gonna be over here. But I'm not expecting straight line. That'd be if it had constant velocity. And this has changing velocity. So it's gonna get slower and then faster. Remember that the slope of the position graph has to do with the speed. The steeper it is, the faster it is. So at the beginning, it's quite fast. It's very steep. And then it gets less and less and less steep, and then more and more and more steep. I'm going to try and draw it and then talk about it. Something, I don't know if I can hit my spot just right, but something like that. So again, we're looking at the beginning and saying, oh, that's quite steep. It's pretty fast. Ooh, and then it gets slower, and maybe even stops for a moment, and then gets faster and faster because the steepness of the graph tells me the speed. If I'm being fancy, the slope of that graph actually tells me the velocity, and this is where one of those big ideas at the beginning comes in, where we're going to try and get the meaning of instantaneous velocity. The velocity changes. I can't ask what the velocity is for this car because it's very different at different times. I have to ask, what's the velocity at a certain time? What's velocity at 0 seconds, or 1 second, or 2 seconds, or 3 seconds? It's different. So what instantaneous velocity means is velocity at a specific instant. And we need to be able to find velocity at a specific instant. And we can't just pick any 2 points and find the slope because the slope is changing. So what we're going to do is imagine that at each point, I want to know the slope of the graph. So at each point, to know the slope of the graph, we would need to find the slope of the tangent line. I'm going to draw in a tangent. For those of you who need a little math review, a tangent is a point that just kisses the graph and doesn't cross it, and it's matching the slope of the graph. So at 0 seconds, that tangent would look, maybe something like that. Hopefully you can see how that pink line is the exact same steepness as that graph. Because that pink line has a negative slope, that tells me that at the beginning, the velocity is a negative number. I'm going to pick a few other points and find the instantaneous velocity. Maybe there. If I was drawing in the tangent there, I'd want to match the steepness of the graph, something like this. You can see how it kisses the graph. It doesn't cross this way. It doesn't cross this way. If it crossed this way, that'd be too steep. Cross this way, that'd be not steep enough. So something like this, drawing in a pink tangent line, and I look at it, and that slope of the tangent line is the velocity at that instant. The slope is negative, but it's not as negative as this. That means the velocity is negative, but not as negative as before. Maybe here. If I keep going and drawing in more tangent lines, and maybe at this point I'll draw in a tangent line, I'll notice that the slope is still negative. The velocity is still negative, but it's a smaller slope than before. The velocity is still negative, but smaller than before. At some point, maybe here, representing when it was at the very top of the ramp, you can see how the tangent line would have no slope. This means the car has no velocity at that instant. So I'm going to match that up and say at this instant, there's no velocity. If I keep drawing tangent lines, all of a sudden I'll see my tangent lines have positive slopes. This might make sense. My object is going in the positive direction now. So the slope of this line is positive. That means the velocity is positive at that spot. And at the very end, we get a very positive slope of the tangent line, a very positive velocity. So in all, maybe we get something like this. It should make sense how that matches this motion. There's a negative velocity that gets less, a negative velocity that gets less until it gets to the top of the ramp, and then it has 0 velocity, and then there's a positive velocity getting faster, positive velocity getting faster. The last piece we want to know about is the slope of a velocity time graph, but this would be a good time to go pause. There's 3 things we're trying to learn. Can you summarize for yourself the first 2 before we move on to the meaning of the slope of a velocity graph? What does instantaneous velocity mean? How can you create velocity time graphs when you have a curved position time graph? So pause, say it out loud.